Hey everybody, this is MoBaller12 here to help quench that knowledge thirst. I know it's been a really long time since I've uploaded videos. Please forgive me, I've been really busy. Hopefully I'm going to start uploading videos on a more consistent basis. I'm aiming for one video a week. I think that's a modest number, that's a realistic number. So stay tuned, because hopefully these videos will help you guys, continuously help you guys with your academic endeavors. So okay, oh yeah, by the way, I also want to thank everybody that has been, commenting on my videos. Those comments that are positive, I really appreciate it. Those comments that are, I'm not going to say negative, but rather critical, thank you, I really appreciate it. Those comments as well. Both groups of comments are really helpful in my growth and the channel's growth as well. Okay, so I really appreciate those comments. So let's get right into this topic. Hybridization. I'm not going to get into the theory or the conceptual aspects of it. I might get a little bit into it. I just want to show you guys how to identify whether something is SP2, SP3, SP, so on and so forth. Okay, so we're going to do two examples. I'm going to identify all the hybrid things in this structure here, and I'm going to do one more structure that caters more to general chemistry students. This is more organic chemistry focused, but I'm going to do one for general chemistry students as well. A structure that relates more to general chemistry that you guys would see. Okay, so again, I think this is the best way to do hybridization. It's clean, fast, to the point, and you guys would get 100% on your quizzes, exams, so on and so forth. Okay, so this technique, I was playing with this one day and I said, you know what, this technique works. Okay, and I started teaching this to other people and they really like this technique. Okay, so what is this technique that I've been blabbering about basically for this past minute or so? This technique entails having written this piece down. This is your bread and butter for this technique I'm about to show you. Okay, you want to typically write out 1s, 3p's, 5d's, representing the amount of orbitals that you have for a given type of orbital. So typically you have 1s orbital, 3p orbitals, 5d orbitals. So the amount of p's, d's, and s never changes. You just want to write this down: 1s, 3p's, 5d's. You could technically write the 7f's, but we don't get that complex in these classes in terms of hybridization. Okay, so you want to write this down. So whenever your teacher gives you a problem, says determine the hybridization, you're going to write this down: S, 3p's, 5d's. Okay, that's easy. And the next thing you want to do is be able to identify, key things in a structure. Okay, what do I mean by that? The things that get hybridized in a structure are central atoms. Okay, don't think of central atoms in its literal meaning. Basically, the central atom has to be the atom in the middle of the structure, like this oxygen, for example. No, that is not the central. That is a central atom, but it's not the type of central atom you guys are thinking. You might be thinking. Okay, a central atom is an atom that's surrounded by other things, like other atoms, lone pairs. So this is a central atom is surrounded by a carbon and lone pairs. This hydrogen, this hydrogen, this hydrogen are terminal atoms. Okay, they're terminal atoms. They surround the central atoms. Okay, so again, central atoms are surrounded by things. Terminal atoms are the things that surround the central atom. So again, this is terminal, 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 so on and so forth. Okay, the things that are hybridized are the central atoms. Very important to know the distinction between terminal, central, and what are the things that get hybridized. Okay, again, central atoms get hybridized. Okay, now let's get into determining how to determine its sp2, sp3, so on and so forth. Okay, what you want to do is so for example, I'm going to identify the hybridization for this carbon, this oxygen, carbon, carbon, carbon. Okay, I'm going to go through each one of those atoms. Okay, so the first thing you want to do is count the amount of groups surrounding that central atom. So for example, in this carbon, okay, through an example you will understand what I mean by groups. So for this carbon you have one group, which is this hydrogen, this other group, which is this second hydrogen, 3, and this carbon group, so that's 4. You have 4 groups. So you're going to look at this little thing we have written down here, and you're going to count off. So we have 4 groups around this carbon atom, so 1, 2, 3, 4. Okay, so it's going to be written as the hybridization for this carbon as S. You have 3 p's, so sp3. So this carbon right here is sp3. Okay, pretty straightforward. Okay, let's do this carbon atom now. So how many groups surrounding it? Best thing to do is pause the video, try it out. Okay, we have This oxygen, that's 1. This oxygen, that's 2. This carbon atom, that's 3. So we have 3 groups surrounding it. We're not counting the bonds, we're counting the things surrounding it. So we have 3 things, 3 groups surrounding it. So we're going to count 1, 2, 3. sp2, right? Because we have 2 p's marked off. So sp2. So this carbon atom is sp2. Okay, the number is typically written as a superscript, as a number like an exponent. Okay, so how about this oxygen atom now? Well, that oxygen atom has this carbon group, this other carbon group, and lone pairs count as groups as well. So you have 1, 2, 3, 4. You have 4 groups surrounding that oxygen atom. So we're going to count off 1, 2, 3, 4. sp3. This oxygen atom is sp3. I don't think you guys can see that because of the glare, but I've written sp3 here just to let you guys know. Okay, I'll move it down to show you sp3. I'll move it back up. Okay, how about this carbon atom? This carbon atom has 1 group, 2nd group, 3rd group, and a 4th group. So it has 4 groups. So 1, 2, 3, 4, sp3. What about this carbon right here? How many groups does that have? This carbon atom has this carbon group and this carbon group here. And as you realize, it is the groups that are directly attached to the thing that we're trying to determine the hybridization. We're not going to count this as another group. We're talking because it's not attached to this carbon that we're trying to determine the hybridization for. Okay, so let's make some things clear. So we have 1 and 2. So 2 groups, so it'll be 1, 2, sp. This carbon atom is sp. Again, 1, 2. Let's do this carbon atom. This carbon atom has 2 groups again. 1, 2. So that is 1, 2, sp. And there you have it. As easy as that. Okay? Hybridization made easy. Okay? Let's do one more example. And this is an example that kind of caters to the general chemistry students, because a lot of the general chemistry students will see structures like the one I'm about to draw. Okay? And we'll call it a day on this video. Okay? So we have this structure here. This is known as xenon, okay? Xenon tetrafluoride. Okay? I'm kind of writing the lone pairs to the side so the glare doesn't get it, okay? Now obviously the fluorine has lone pairs. It has to fulfill its octet. Technically the xenon violates the octet, but it can, because it has more space where other things can bond to it. It has more space to, to accompany, to home, to house these extra electrons. Okay, so don't say that, oh, you drew the structure wrong. The structure is correct. It's just the reason why it violates the octet rule is because it's beyond that 2nd row, like your teachers, I'm sure, have taught you. So let's do the structure. This structure, again, it looks crazy, but it's very easy to do. So we're going to count the groups surrounding it. So we have 1, 2. I'm going to worry about the atoms first. So 1, 2, 3, 4. So that is 4 atoms so far, or actually not atoms, but 4 groups. 5, 6. So 6 things are around this central atom, right? These are terminal things. So 6 things. So we're going to count off 1, 2, 3, 4, 5, 6. So you actually leaked into the D section. So it's going to be, the hybridization for this xenon is going to be sp3, right? Because we have 3 p's and we have 2 d's, so it'll be d2. Bada bing. Okay, that's it. Easy. Okay, and that's the end of hybridization. Nice and easy. In my opinion, again, the best technique to do hybridization. All the best. And stay tuned for next week. Hopefully I'll be uploading a new video. Take it easy, guys. All the best.